Let's determine an empirical and molecular formula from mass percents. Mass percents can be determined from mass analysis using combustion experiments, while molar masses of samples can be found from mass spectral analysis. In this example, a sample of compound contains 30.46% nitrogen and 69.54% oxygen by mass. The molar mass of the compound is found to be 92.02 grams per mole. Determine the empirical and molecular formula. Let's determine the empirical formula first. This is the mole ratio of nitrogen to oxygen. Then we can determine the molecular formula from the empirical formula. Because we're dealing with percentages, we can start by assuming that there are 100 grams of compound, because each percentage can be converted directly into grams. That is, 30.46% nitrogen is 30.46 grams of nitrogen, and 69.54% oxygen is 69.54 grams of oxygen. Recall, the ratio of masses don't really matter to us. What does matter to us is the ratio of moles. So next, each mass can be converted to moles using the element's atomic weights. The moles can now be compared. Remember, we want the simplest whole number ratio of moles between nitrogen and oxygen. So we can obtain this by dividing by the smallest moles. Here, we'll divide each value by 2.174. The ratio of nitrogen moles to oxygen moles in the compound is 1 to 2. And the empirical formula is NO2. Going back to our problem, we have determined the empirical formula. Now, let's determine the molecular formula. We need to multiply the empirical formula by some multiple n. N equals the molecular formula molar mass divided by the empirical formula molar mass. Here, the molecular formula molar mass, 92.02 grams per mole, was given in the problem. The empirical formula molar mass is the molar mass of NO2, 46.01. We can distribute the ratio of 2, and the molecular formula is N2O4.